Imagine you're getting ready for the day, and as you look into the mirror, your reflection suddenly talks back to you. Sounds like a plot of a fantasy movie, right? But what if I told you from a scientific perspective, it's not entirely out of the realms of possibility? Bet that piqued your curiosity. To understand this, let's delve into the fundamentals of how mirrors work. When light strikes a mirror, the mirror's smooth surface causes the individual light waves to reflect at the same angle. This creates what we perceive as our reflection. Now, coming to the interesting bit, what if we could manipulate this reflected light to make it generate sounds or even form meaningful sentences? The science behind this would revolve around exploring the principle of light's duality, which means light can behave both as a particle and a wave. Sound, on the other hand, exists purely as a wave. Could we manipulate light waves to mimic the characteristics of sound waves? In other words, can light particles, or photons, be tweaked to vibrate air particles, thus creating sound? It's not as easy as it sounds, but let's entertain the idea. To begin with, we'll need a new type of mirror, not the regular one hanging on your wall. We might need to integrate some advanced technology into it, making it capable of manipulating the behavior of photons. Let's imagine a mirror that's equipped with tiny sensors capable of detecting the photons hitting its surface. These sensors would then convert the photons into electrical signals. The electrical signals could then be further processed to generate sound waves in the air. Voila! Our mirror is now capable of speaking, but how can it produce meaningful sentences? Well, it would require a sophisticated interface that can analyze the reflected light patterns and convert them into recognizable speech. Imagine the possibilities. You could have conversations, get daily weather updates, or even hear compliments from your reflection. But keep in mind, this is all purely hypothetical at the moment. The technology required for such a mirror is far beyond our current capabilities. However, advancements in fields like nanotechnology and photonics are pushing the boundaries of what we thought was possible. Who knows what the future holds? Maybe one day, we'll witness the birth of a talking mirror that revolutionizes human-machine communication. Until then, let's continue to marvel at the wonders of our world and imagine the possibilities. Now let's dig deeper into the science behind this fascinating concept. The process of sound generation from light involves controlling the behavior of photons. This manipulation requires precise control over the polarization and frequency of light waves. Polarization refers to the orientation of light waves as they travel through space. By altering the polarization, we can influence whether the reflected light carries sound information or not. Frequency, on the other hand, determines the pitch or tone of the generated sound. Combining these two elements, we can create a mirror that transmits specific sounds with great precision. Of course, achieving this level of control requires advanced techniques and materials. Researchers are exploring nanomaterials and metamaterials to enhance our ability to manipulate light waves. These materials offer unique properties that allow for unprecedented control over light and sound interactions. By harnessing the power of these innovative materials, we may unlock the secrets of a truly interactive mirror.